Hello, everyone. Welcome to our daily SAT Math Question of the Day, where we have Professor Emeritus Seth Chaiken from University at Albany and his brother Joel Chaiken to help you understand how to do these math problems and, more importantly, how to approach these things. Because we don't know what's going to be asked, but we know the approaches are generally all the same. So here we have our question of the day. It is a polynomial expression, fraction.
Rational polynomial.
Yes, Seth has the technical word for it, and we're asked to see what that thing is equivalent to. Seth, you want to give it a shot?
Yeah, okay, here's a shot.
Okay,
what does equivalent mean? That means that the left-hand expression, the given expression, gives you a value for every value of x you put in, and for it to be equivalent means that the equivalent expression should give you the same value for the value of x you put in. Okay, so the best approach for this problem is ruling out the answers that are impossible.
Right.
Okay, so x plus 3 does not divide 5x minus 2. You can't simplify this by dividing out x plus 3 to get a constant. So this expression is not an expression for a constant, but expression A is a constant.
Right.
And I'm not going to tell you what it is. Similarly, expression B is not a constant. So we could rule out A and B completely.
Yeah. You could also throw 0 into X.
And so that leaves C and D. Well, all you have to do is rule out one of them by finding a value of X where for which the value of the expression, let's call it E, is different from the expression you're asked to rule out. So let's try. Let's say x equals 0. Well, if you plug in x equals 0, you get minus 2/3. So if you set x equals 0, we get 5 minus 17 over 3, which is a ridiculous number because it's fractional. It's not an integer. But maybe, maybe it is. I don't know. So it is a third. Get minus 2/3. Well, but I'm too lazy to. I don't want to. I'm too flustered to even do the math here. But now let's try x equals 0 in part C. That's easy. We get 5 minus 2/3, or rather.
It's but 5 minus 2/3. Put the x equals 0 in here first to see what that is.
Yeah. X equals 0, you get minus 2/3.
Yeah, minus 2/3.
If you put x equals 0, you get 5 minus 2/3, which is certainly not the same as 2/3.
Right.
They're not equal, so we rule out C, so the answer must be D.
Yeah. Interesting problem. It's just as you were going through the solution, I realized this is an interesting problem because the most efficient way to do this is brute force. Is guess. They call guess and check. You actually never actually have to do anything except check the answers. It's interesting, right? That's what they're testing you to see whether you can solve a problem like this just by pulling the trick of just checking the answers. It's interesting, right?
Yeah. Right, and I didn't even have to bother simplifying 5 minus 17/3.
Yeah. Almost.
But let's check the bet to see if it's 2/3. Well, 5 is what? 5 is 15 thirds.
Yeah.
You subtract 17 thirds, and we get negative 2/3.
Yeah.
So the SAT writers did not make a mistake in forming the question.
Yeah.
And our strategy of ruling out the 3 responses that are wrong, and then answering the remaining response without testing it further is a good strategy for SAT. But if you're launching a spacecraft to go orbit the moon? No, it's not a good strategy. You have to check everything that you are assuming to be true. You have to check that it really is true.
Right.
But that's the difference between SAT and genuine achievement-oriented technology, like getting to the moon.
Right. Well, right now we're just focused on the SAT, and this is a really unusual problem in that the only practical way to do it is to actually put 0 in for x and see which ones are equivalent to when x is equal to 0. They could have been really nasty here. Couldn't they have made 2 equations?
No. What you could do is...
They really wanted to make this hard.
No. A practical way of doing it is dividing.
Yeah, but yeah. Well,
anyone
we can
could do
later.
this. So 5, it comes 5 times x
I'm going to move
is
it.
5x. Okay, 5 times x is 5x. 5 times 3 is 15. Subtract them, and we get subtract them. We get negative 17. So the answer is 5 plus the remainder of 17. The remainder of 17 divided by 5.
Right. What Seth did...
Which is what this
divide
says.
by x plus 3.
7, I meant by 3. By 3. Yeah.
No, to x plus 3.
Yeah,
Seth, you're blowing it. X plus 3. Seth's being a little messy. Okay, so what we'll do...
I'm being a little messy,
So
okay.
you know what we'll do? We'll end the video here.
Okay,
Anyone who wants
get it
to
right.
stay on...
Yeah.
Seth,
You divide...
Seth,
You could simply divide using polynomial division, and the answer will be 5 plus negative 17 divided by x plus 3, which is this expression.
That's right. Yeah, that's what's called
However, it's a lot faster to pick the answer by quickly observing, ruling out A and B because they are constant expressions, and then checking C and D for the easiest value of x to check. So, well, what might happen is they'll give you a distractor in which substituting for x of some number that the SAT people would invent, and you might well guess, will give you the same number.
Right. Yeah.
If you get C and D to come out the same for a given x, that is not a reason to either accept or rule out either of them. You have to go for a different number.
So wait, so I have two comments. One, you said that you could rule out A and B because they're constants. Yeah. My argument is that you don't have to think that extra step. You can rule out A and B because neither of them equals 2/3 when x is equal to 0. When x is equal to 0, this thing equals negative 2/3.
No,
this never equals this doesn't equal negative 2/3. So it's impossible. It's impossible.
Yeah, I could do that way.
That way, that's one
it's easier to see. It's easier to see something as a constant than to even think about what its value is.
No, but that requires a little higher. Miss Seth, you're like a math genius, okay? Most people are not a math genius. Trust me, most people. Raise your hand. You know, of course, we're not going to see you, but raise your hand if you saw that. Raise your hand if you use that logic. I'm not a math genius, okay? And that's where we differ. That's why we work together, right? You're the math genius.
Look, if you were an engineer, you're an engineer. If you saw a table that gives you values, what happens in engineering, they'll give you a table for different ranges of x, of a different formula for something that's some quantity that's of interest in engineering. Sometimes those formulas are constant.
Yeah.
And if you see a formula that's constant, it's immediate that you know it's constant.
Right. No,
Right.
but I still think it's more efficient just to put x and put 0 in here. The answer is negative 2/3. Which one is equal to negative 2/3? Now, what Seth said about a distractor, if the SAT wanted to make this a much harder question, they would have changed. Which is the answer? They would have changed this one.
C.
They would have changed this one to x minus 2/3.
Yeah.
Ouch.
Right. Yeah.
Ouch.
Yeah.
Hurts.
That would be
painful.
bad.
But that changed the question from a 12-second question, 13-second question, to a question where you really probably actually may have to do that.
Yeah.
Right?
Yeah. However, with a little more experience, you could rule out x minus 2/3 because that is a first order polynomial.
Yeah.
And the original expression is a ratio of two polynomials each first order.
Again, you're talking about genius here. The other possibility you could have checked.
It's not a matter of genius. It's a matter of going to school another semester.
Seth, you're so overeducated. You have a PhD in math. Come on.
Yeah.
Come on. I only have a PhD in
Take AP math and you'll learn all this stuff.
Yeah, but they're not there yet. The other thing you could have done here is you could have checked another point, right? You could have put x is equal to 1 here. And then you would have said, then you could have checked, right? Maybe that would have been more efficient. If they say this was an answer, you could have put x is equal to 1 here and then check to see which one works. Right? And then you could have quickly ruled out this one. If you put x equal to 1 here, I'm sure it doesn't work.
Let me give you I have to give you a true confession.
Okay, go ahead.
My true confession is when I first saw this problem, I, without writing anything on paper, I arrived at a solution using the method I described, and the solution I picked was C.
Yeah, how did that happen?
Because I looked at it and I looked at x equals 0. I saw the minus 2/3, and my silly eye missed the 5.
Yeah. That's why it's
watch out.
That's why it's good to proofread. That's why it's really good. Don't be complacent. Do not be complacent on these tests.
Yeah.
Stay alert and proofread. You proofread your emails.
No.
We should really proofread our videos. We don't proofread our videos.
Proofread your text messages.
Proofread your text messages.
Proofread your tweets.
Proofread everything. And that's right. That's right.
Yeah. So this is distracting because see the shape of this.
Yeah.
They put in minus 2/3, and there's the same shape here.
Right.
So if you're just trying to use your eyes, you'll see a superficial similarity of pattern.
They did that purposely. Of course, they did that purposely.
Yeah, and I fell into it. I told you I said, okay, the answer is C.
Wow. Okay. Yeah,
and only today did when I talked it out to you, did I realize, I was wrong.
So I don't think we'll subject people to do more of the polynomial long division because that's not really on the SAT. But that is 11th grade math. You're doing it now probably in school. But Seth did that polynomial long division, which we're not going to go over. Oh, have you ever heard of a thing called synthetic division? Is that
new? Yeah.
Oh, yeah. Good. Did you do that in high school?
Well, I'll tell you the truth about that. I was taught it.
Yeah.
And I didn't practice it, and I realized that you could do just as well by plain division where the x appears explicitly, and doing it with the x explicit makes it much easier to make it neater. And so I never cared for synthetic division.
Yeah, I'm not a big fan of it because it requires you to memorize a procedure. It's like I call it voodoo math. And stay away from
voodoo math.
Voodoo math.
Cool.
I say stay away from voodoo math. If you just do it because regular polynomial long division requires you to understand stuff, and I stay away from that stuff. I can't. I have a mental block against synthetic division. But
me too. I see we're brothers.
Right.
Yeah,
But I
yeah.
have all the books
Well,
here.
synthetic division was popular to teach in the days before computers
Yeah. Right. Of
because
course.
people who did applications or research or applications or entertainment or research in math had to divide polynomials, and synthetic division enables you to scribble more quickly.
Right.
So, but today you could get calculators that divide polynomials.
Right.
Right.
Yeah. And frankly, nobody is building technical big engineering projects in high school. So it's better to learn the concepts behind the math rather than the cheap tricks. It's sort of silly.
Yeah.
Why they teach it. Okay, I think we've killed this problem to death.
Okay.
We looked at it from all different perspectives, which is a good thing to do in an SAT question, is to look at it from different perspectives. Particularly when you're studying for the tests, try to look at the problems from different perspectives, so that when you actually take the test, your brain sort of like, you have different choices on how to do the problems. It really makes you more confident, gives you more power. Okay?
Okay.
So please like this, dislike this, all comments welcome, constructive, destructive, anything. We just want to know what you think. Okay, everyone. Have a great day. Bye-bye.